Welcome in the fourth section of our course. In this section, we'll be looking at the Spark Machine Learning and Spark Streaming. So we'll be introducing Spark Streaming and streaming world of processing events. We'll be learning Spark Streaming API to write streaming jobs. We'll write couple production-ready jobs that could be used in real production systems. We'll be creating streaming application that loads data from Apache Kafka, that is a queue. And in the first video of this section, there will be an overview of Spark Streaming and streaming world. So we'll see a Spark Streaming architecture. We'll be looking at the micro-batches approach of processing events. We will be looking at the relation between latency and throughput, and how latency affects throughput, and how throughput affects latency. At the end, we will see how Spark Streaming achieves failure recovery by using checkpointing. So, first question is when to use streaming. So, streaming should be used when we need to process events in near real-time fashion. If we need our results to be available in seconds. So, for example, if you want to build a system that performs a fraud detection or anomaly detection, and we want to react very quickly on users' behavior, we need to employ some kind of streaming approach. So how Spark Streaming does look like? So Spark Streaming is an API that is built atop of Spark Core API that we already learned about in previous sections. Spark Streaming has a Spark SQL API, so we can use data frames and SQL-like interface as well, and also MLlib could be used from Spark Streaming. And typically, Spark Streaming job has an input that is a Kafka or Amazon on Kinesis or Akka, so this is a queue that is sending data, events to Spark Streaming, or also it can fetch data from some static source, like for example Cassandra, HBase, MySQL, and so on. So typically Spark Streaming job is fetching data from some external input and then perform some processing. After that, results are saved to some external data storage system. It could be saved back to Kafka or to Cassandra, HBase, depending on the read pattern. So if you want to query that data in a very low latency and in the random manner, we could save it to Cassandra. So the pros of Spark Streaming is that it has an uniform API with Spark Batch. And DStream is a primary abstraction containing multiple RDDs. DStream contains n number of RDDs. So if we have a DStream abstraction, it has multiple RDDs underneath. So when we will be processing DStream, we will be iterating over every RDD in a DStream. And within a window-based operation, we will get multiple or 1 or 0 RDDs. And then we can perform some operations like, for example, mapping, filtering on everything that RDD is containing. But we need to remember that DStream can contain multiple RDDs. And Spark Streaming employ micro-batches approach. So data arrive in batches. And we are configuring the batch duration. All events that arrive within duration are packed into one batch of data. So we will have some kind of high frequency input data stream. This will be consumed by Spark Streaming job and batched into multiple batches of input data. Then Spark Engine within our program will be working, is processing those micro batches and sending results further. So when we will set a batch duration, we have an impact over latency and throughput. So if the batch duration is longer, we get the higher throughput, but also higher latency. And if the batch duration is smaller, we will get lower latency, but also lower throughput. So let's see an example comparison between latency and throughput and how that batch size in second parameter affects them. So if you will set batch size to, for example, 5 seconds, then latency, worst case latency, will be 5 seconds. because we need to wait 5 seconds before the batch will be ready. And throughput will be higher, so we will be able to process, let's say, 1000 events per second. On the other hand, when we will set batch size to 1 second, the worst case latency will be equal to 1 second as well, but throughput will be lower. So if we need lower latency, we need to set that batch size to lower size, but throughput will be lower as well. And Spark streaming has a failure recovery mechanism. It uses checkpointing, so it saves the actual intermediate RDD data to a reliable distributed file system. In case of the worker failure, it can resume computing by loading checkpoint data.